is a binomial distribution, and this allows you to start answering questions about Gambler's Ruin. What's the possibility that based upon some number of wells that would be drilled in a particular play, what is the likelihood that all of them will be failures, that is Gambler's Ruin? And alternatively, you could ask, given a average chance of success, and you can answer questions about what is the likelihood of me having one or more discoveries or two or more discoveries, etc. So the input cells are in yellow in here, so that you can go in and say, I have an average piece of G of 25% and 35% and maybe 55%. And you can, based upon those, you could say, what is the likelihood of having all of the wells to be failures? So, of course, if you only drill one well, then it's going to be the complement of the input chance of success. And you can see as you increase from 1 to 2 to 3 to 4 wells, what the likelihood of having 0 successes decreases quite rapidly. But in order to get to a probability of having a near certainty of having one or more geologic successes, you have to drill a large number of wells. This is a very important function to be able to communicate to management when you are contemplating what should be our dry hole tolerance in a play. The second chart and input down here allows you to input an average probability of success, and then you can say, what is the likelihood of me having one or more wells, successes, 2 or more successes, 3 or more successes, and it will represent what is the likelihood of associated with each of those. There are questions to the right which just address Gambler's Ruin. So, for example, you can say with an average probability of 30%, and my management wants to achieve at least a 70% chance of one discovery. So let's go back here and let's put in 30%. And you want to achieve at least a 70% chance of success in here, then you're going to need to be drilling between 3 and 4 wells in order to achieve that. So these questions over here are useful for helping to answer questions with regards to what should be the number of wells that you're willing to drill in a particular play. Similar type of question can be asked once again for dry hole tolerance associated with an input play chance of success, the shared chance in here, the independent prospect success ratio. The product of those, of course, represents the average prospect piece of G, and you can put in what is the probability of exceeding some commercial threshold, and look at the average prospect piece of C. And then based upon those inputs, the chart over to the right is saying, is representing what is the likelihood of one or more geologic success in red, one or more commercial success in green, as you increase the number of wells which you are willing to drill. So for example, if you have a dry hole tolerance of 3, then the probability of one or more successes is of geologic successes is 53%, one or more commercial successes is 41%. And you can also ask it for a given confidence. If you wanted to achieve a 70% confidence of having one or more geologic or one or more commercial, then you're going to have to drill either 6 wells or 9 wells for a commercial success. Next is the ability to go in and look at what is dry hole analysis and what is contributing to failure associated with a program of wells. This is quite useful for helping you to understand if there are potentially technologies that might be brought to bear to understand or to better be able to reflect what is the likelihood of success and failure associated with a particular component. This matrix is available for the typical Rosen Associates 5x5 components, and there's also one with a 8x8 matrix with different subcomponents associated with that. The way that this matrix works is if you focus on a row, then if you are able to identify in a population of dry holes what was the reason for failure, there in total in the matrix, I've got 77 dry holes that have been identified. And you can say that 4 of those were the actual reason for failure was source. And I recognized in my pre-drill assessment of the chance components, the critical chance factor, that is the lowest chance factor in 2 of those 4 was associated with source. On one of them, the critical factor was identified as timing of migration. Another one was closure. So I was able to predict accurately 2 out of 4 times, 50% of the time, that source was going to be the reason for failure associated with that. So you want to have a high proportion that where you properly recognized what was going to be the critical risk that can contribute to failure. Look at the containment example in here, and here there were a total of 21 wells that failed for containment reasons, and 17 of those were recognized as where containment was the lowest chance component, with only 4 attributed to other values. So a very high probability and a clear recognition that containment and seal was an issue. Contrast that with the reservoir here, and there were 28 wells that failed for reservoir, but only 8 of those were actually predicted as the lowest chance of success was with reservoir. So we did a poorer job of recognizing that reservoir was a problem in these 28 dry holes. And so if there is some technology that can be brought to bear to better understand that, then hopefully we could improve our recognition of where reservoir was a potential problem. The last item in chance of success is that there is a Bayes theorem reversal, such that you can go in and capture probability values for 2 events, and then it will calculate what is the conditional probability of the second event given success in A. Here it's actually representing in red in here that the conditional probability that is calculated based upon that is actually in excess of what Bayes' theorem would allow. So this is not a viable representation associated with these particular entities. So you would need to modify the inputs to get that to be a viable assessment. I'm not a very good Bayes explainer. I don't really understand Bayes, so I'll leave this to engineers who are generally better at understanding Bayes than I am. Let's go